Howdy everyone, today we will be going over S-domain analysis with initial conditions present. So for our first problem, we're going to solve for Vx, which you can see is right here in this node. For when we solve for initial conditions in the S-domain analysis, that's the first step. We have to look at what sources we have. On this right-hand side, we have a source voltage of 4 UT. This UT means that there will be no voltage existing before time 0, so this does not make initial conditions. However, on this left-hand side, we do have a 5 U of t, but the U of t only accounts to the 5, so therefore this 2 voltage exists before time 0. So this means that there will be a source of 2 volts coming into the conductor, but there will be none flowing into the inductor. Whenever we draw this circuit in the S-domain, we can go ahead and start by moving the voltage sources. The source on the right translates just easily into 4 over S. This voltage on the left, however, we need to account for both the 2 and the 5, so now we have 7 over S. For the resistor, we know that resistors just translate directly into S-domain, and the inductor is just going to be multiplied by S, and then these are in units of ohms, these impedances. And whenever we translate a conductor into S-domain, its equation is 1 over SC. Our value of capacitance is 1/2, so this translates into 2 over S, again with ohms. Now for the purposes of this video, we will include our initial condition in parallel. When including our initial condition in parallel with our conductor, this will result in current flowing in this direction, and the equation for this is C times V 0 minus. So this is for the conductance, which is 1/2, and the voltage existing before time 0, so we found it to be 2, therefore this is 1 amps. We can just go ahead and write 1 right here. Now that we have initial conditions done in our S-domain circuit, we can go ahead and start solving. Now, to solve for V of x, we will be using nodal at V of x. To approach this problem, we will start with going down each and every single branch, just like that, to solve for our V of x in our nodal equation. So first, we have V of x over 1, our impedance is just the 1 resistor, plus Vx minus 4 over S, all over our impedance of 4S, plus Vx minus 7 over S, all over our impedance from the of 2 over S. And then for this right here, we can see that the current is going with the flow, so therefore we will have a positive 1 for the current, and this will all equal 0. Now we can go ahead and write this simpler, and we will get Vx of 1 plus S over 2 plus 1 over S squared minus 7 over S all over 2 over S minus 4 over S all over 4S plus 1 equals 0. Now that these are all factored onto V of x, we can move this part onto the right-hand side to have a nicer equation. So now we get V of x of 1 plus S over 2 plus 1 over S squared equals negative 1 plus 7 over 2 plus 1 over S squared. Translating this into one single fraction that we can better manage, we get V of x of 2S squared plus 4S plus 1 all over 4S. And simplifying this side as well, we get 5S squared plus 2 all over 2S squared. And all we did was make them have a common denominator, and we got this equation. Now, to directly solve for v of x, we need to divide by this on both sides, which basically means we will be multiplying by the reciprocal of this fraction. So we get v of x equals 5s squared plus 2 all over 2s squared times 4 over s 2s squared plus 4s plus 1. Right off the bat, we can see that some numbers cancel out here. This 2 will make this 4 go to a 2. This s will get rid of this power of 2. Now we get 5s squared plus 2 all over, multiplied by 2 from this part, all over 2s squared plus 4s plus 1. Now we can go a step further and simplify v of x equals 5s squared plus 2 all over s squared plus 2s plus 1/2.
So now that we have v of x, we're going to solve for partial fraction decomposition, and we're going to want to factor out the bottom by doing the quadratic formula. So we're going to do -2 plus minus square root of 4 minus 4 times 1 times 1/2 all over 2. And then once we solve that out, we're going to get -1 plus minus square root of 2 over 2. And then we're going to separate it into partial fraction decomposition by doing a over s plus b over s plus 1 plus square root 2 over 2 plus c over s plus 1 minus square root 2 over 2. And then all of this is equal to right there. And then we're going to solve for a, b, and c. So a is 5s squared plus 2 times s all over s times s plus 1 plus square root 2 over 2 times s plus 1 minus square root 2 over 2. And then we're going to plug in 0 into all of the s's, cancel these out. And once you solve for a, you get 4. When we solve for b, we're going to do 5s squared plus 2 times s plus 1 plus square root 2 over 2 all over s times s plus 1 plus square root 2 over 2 times s plus 1 minus square root 2 over 2. And we're going to plug in the opposite. So we're going to do -1 minus square root 2 over 2. And once we plug in this into all of the s's, we're going to get 6.864. Once we solve for c, we're going to do 5s squared plus 2 times 5 plus 1 minus square root 2 over 2. And then we're going to do this over s times s plus 1 plus square root 2 over 2 times s plus 1 minus square root 2 over 2. And we're going to cancel these out. S is going to be equal to the opposite. So it's going to be equal to -1 plus square root 2 over 2. And once we plug in this into all the s's, we're going to get -5.864. Now we're going to put a, b, and c over their original. So we're going to do 4 over s plus 6.864 over s plus 1 plus square root 2 over 2 minus 5.864 all over s plus 1 minus square root 2 over 2 is equal to the original. So 5s squared plus 2 over s squared plus 2s plus 1. And then we're going to want to convert all of these into the time domain. So we're going to use the Laplace transform table. And the inverse of 4 over s is just 4. And the inverse of 6.864 over s plus 1 plus square root 2 over 2 is 6.864 e to the -1.7 positive 1.707 t, and we get 1.707 by adding 1 plus square root 2 over 2. And then the inverse of negative 8.864 over s plus 1 minus square root 2 over 2 is negative 5.864 e to the negative 0.292 t. And then all of this is multiplied by u of t, and this is all in volts. So this is your final v of x in the time domain. Thank you.